In this video, we are presenting the industrial use case of intuitive map editing for robots. For the context, we at IdealWorks build autonomous mobile robots. Here we show the robots in operation. The robot navigates freely in an industrial environment to pick up what we call a dolly from a pickup location to a drop-off location. These locations are called POIs, points of interest. To configure the POIs, the operator drags and drops the assets to the right coordinates on a browser-based fleet management software that we are seeing now. We can see the robot's 2D occupancy map with different assets manually placed on the map. The operator can modify the occupancy map by erasing some obstacles that were captured at the time of mapping and that are no longer relevant to the robot. The rectangles we see on the map are dolly's positions. This is how the robot knows where to go, either to pick or to drop material. Placing the assets at the right position is error-prone because the user must estimate on the 2D map the coordinates corresponding to the desired position in the real world. When a mission is sent to the robot navigates to the indicated destination. Here we see the robot going to the POI to pick up the dolly. As mentioned, the process is error-prone as the operator might need to do different iterations to set the right coordinates on the 2D map. That's why we have developed a HoloLens Human-in-the-Loop XR app to capture, edit, and enrich the robot's map in XR. We are going to navigate through the different functionalities of the HoloLens app. First functionality is capturing 3D information to map the area. Different robots types operating in the same area need different maps. By capturing 3D information, the needs of the different robots could be satisfied by horizontally slicing the 3D map to export the 2D maps for the robots. Another functionality is labeling unknown object to add semantic tags on the assets surrounding the robots in operation. Furthermore, as we are going to see here, the 3D map can be edited by erasing objects captured at the time of mapping that might not be needed or might not be relevant anymore. You might notice we are speeding up the video for convenience. Another functionality shown here is adding assets in XR, or what we call in situ. For example, adding a robot 3D model to configure the pose of a parking spot or to test if a robot actually fits in the place and if the place can be used as a parking location. An alternative approach to manually adding 3D models is 6D pose estimation to automatically track objects of interest. We track the objects based on their 3D geometry. Then we position the 3D model into the scene based on the localization and orientation of the user relative to the tracked object. Here we see the 3D model of the mobile robot overlaid on the real robot. Likewise, we are going to overlay the 3D model of the dolly on top of the real dolly. That's the improvement we propose compared to the traditional way to configure the pose of the dolly to mark pickup or drop-off locations. What you are seeing here is a dolly 3D model overlaid on top of physical dolly. All done in situ in XR. Finally, many additional features to make the lives of the operators easier by being able to label captured data while being on-site without having to do multiple visits to the shop floor.